For decades, the study of early childhood development has operated in isolated silos. Researchers typically align themselves with one of three primary camps: biological maturation, behavioral conditioning, or emotional drives. This leaves educators in a difficult position. When forced to choose between these competing theories, they are left with a fractured understanding of the developing mind. Building a classroom methodology on just one of these pillars means ignoring the mechanics of the others. You cannot optimize a child's cognitive potential if you are only addressing their behavioral outputs or their physical growth. Operating without an integrated psychological model forces teachers to navigate with incomplete maps, leading to instructional methods that fall short of what the human brain requires to thrive. In 1972, the Swedish government released official report SOU 1972-26, a rigorous examination of preschool pedagogy that sought to resolve this exact problem. The report bypasses the fragmented theoretical camps by treating human development as an epigenetic interaction. Physical biology and the social environment do not operate independently. They are continuously rewriting each other. The authors proposed a highly structured theoretical framework. It maps human development from molecular biology at the base up through Jean Piaget's cognitive structures, and finally into Erik Erikson's models of ego development. To understand how this operates in practice, we must construct this developmental stack layer by layer, leading to the practical methodology of dialogical pedagogy. Pedagogical efficacy cannot exist in a theoretical vacuum. To teach effectively, we must trace the physical wiring of the brain all the way up to the complexities of human social interaction. At the foundation of this stack is neurophysiology, the unalterable baseline of all human development. Genetic structures do not dictate a rigid timeline of learning. Instead, they provide a latent competence program. The biological capacity is present, but it requires environmental activation. That activation happens at the molecular level. When a child encounters environmental stimuli, it triggers the synthesis of RNA molecules and proteins within brain cells. This stands as a physical consequence. Active learning and exposure to complex sensory environments physically thicken the cerebral cortex. We see a similar physical scaling in the cerebellum, which experiences rapid growth during the first 4 years of life. This specific structural growth provides the necessary hardware for a child to coordinate complex movement, develop spatial awareness, and eventually manipulate their surroundings. The environment functions as a construction site for the brain's hardware, where physical friction translates into structural growth rather than simple information storage. Moving up the stack from biology, we reach the psychological layer, where early 20th century theories attempted to map these physical changes into observable action. We begin with behaviorist learning theory. Behaviorism operates on operant conditioning, the premise that the environment shapes a child's actions through a calculated system of positive and negative reinforcement. The limitation here is mechanical. Behaviorism treats the internal biological organism as an opaque black box that merely receives inputs and produces outputs. By ignoring the child's internal cognitive constraints and the specific stage of their biological maturation, behaviorism offers an incomplete model of learning. Psychoanalytic theory shifts the focus entirely, examining the tension between internal emotional drives, the id, and external social demands. This tension forces the development of the ego to process reality and the superego to act as a conscience managing these conflicts. While this brilliantly maps a child's emotional motivation and conflict resolution, it lacks a mechanism to explain logical and intellectual progression. External behavioral conditioning cannot explain how a child actively builds a complex intellect, and internal emotional mapping cannot explain it either. A synthesis is required. To solve the intellectual progression gap, the Swedish report turned to Jean Piaget's cognitive theory. Piaget approached the mind as an architect of cognitive structuralism. He argued for an interactionist approach. A child is not passively molded by rewards or drives. They actively organize their experiences into increasingly differentiated hierarchical structures. These cognitive stages are progressive. Each new intellectual ability relies directly on the rigid architecture constructed in the previous stage. Piaget's elegant model maps the form of human thought perfectly, but it misses a crucial element. the emotional drive that dictates why a child chooses to engage with the world in the first place. The solution presented in SOU 1972/26 is to fuse Piaget's cognitive scaffolding with Erik Erikson's psychosocial model of ego development. By merging the geometric form of cognitive development with the internal emotional drive of the ego, the theories operate as a single engine. This integrated model bridges the historical divide. It explains the mechanics of how a child processes the world cognitively, while mapping why they are motivated to do so. With the theoretical stack complete, we can evaluate applied classroom methodologies and observe how this framework dictates the actual behavior of an educator. The first applied model is Vermittlings Pädagogik, or the transmission model. This is a strictly authoritarian approach. Information flows rigidly downward from a large, active adult to a small, passive child. The transmission model fails because it relies on behaviorist rote compliance. By forcing a specific output, the educator actively bypasses the child's internal cognitive structuring. In reaction to this, many educators adopted the opposing Utvecklingspädagogik, or the developmental model, heavily influenced by Arnold Gesell's maturation theory. This approach is rooted in historical observation, where researchers cataloged natural behavior stages from a distance. The core flaw of the developmental model is the assumption that educators should merely curate an environment, step back, and passively wait for a child's biological readiness. This creates an isolated dynamic. The adult watches the child, but no meaningful information or vectors are exchanged. Leaving a child in this hands-off human vacuum deprives them of the normative and emotional friction required to spur actual ego development. Both authoritarian transmission and passive observation fail in the classroom. They reject the epigenetic reality that development requires active, mutual interaction. The 1972 report concludes that the only scientifically sound methodology is dialogic pedagogic, the dialogical pedagogical model. Its core mechanism is a continuous, bidirectional cognitive and emotional feedback loop. It demands rigorous, active participation from both the adult and the child. This is a process of mutual restructuring. The adult and child continuously exchange vectors, altering their own cognitive shapes based on the other's input. The educator's role is not to simply provide answers, nor to grant passive space. Their job is to provide structured intellectual and emotional friction. Encountering this calculated friction forces the child to actively restructure their own cognitive scaffolding and refine their moral frameworks. This pedagogical friction connects directly back to the biological substrate. Rigorous, challenging dialogue provides the environmental stimuli required to drive molecular RNA synthesis and thicken the cerebral cortex. This represents the physical outcome of the dialogical method. Intellect emerges from this active construction project, transforming latent biological potential